Alright, so here's a couple extra examples of what we did today in case you need some extra work with this. First one is a linear inequality example. So we see that we have this line. It's in slope-intercept form. We should identify the slope is -2 and the y-intercept is 5. So we can first sketch this by plotting our y-intercept at 5. Slope is -2, so we'll go down 2 and over 1. Because of this inequality, our boundary line is going to be dashed. Rather than solid. Now we have to add the shading. Since this is in slope-intercept form and it says y is less than, the y values get less down here. You could also determine this by testing a point. Since the line doesn't go through 0, 0, I would test that. The math is easier. So we should see that 0 is less than -2 times 0 plus 5. This is a true statement. Therefore, 0, 0 is part of our solution. We want that to be where we shade. Okay, I'm going to go to example C and just do a quadratic example. So first we need to graph this boundary. It's already solved for y, so we could find the y-intercept, which means we put 0 in for x, so it's at 0, -5. We could find x-intercepts by putting 0 in for y. So we have to solve this equation. And we get the solutions x equals 5 and x equals -1. So our x-intercepts are 5, 0 and -1, 0. Then the other point we always want to find is the vertex. So a is 1, that's the coefficient of x squared, b is -4, and c is -5. Notice the c value is always what gives us our y-intercept. For the vertex, we find the x-coordinate by finding opposite of b over 2 times a. So for this quadratic, it would be 4 over 2, so the vertex will have an x-coordinate of 2. To find the y-coordinate, we're going to plug that x value in. So to find that, we'll do 2 squared minus 4 times 2 minus 5. So that will be 4 minus 8, which is -4 minus 5, we'll get -9. Now we start plotting all this. So the vertex is at, and this will open up because our a value is positive. So 2, -9 is our vertex. Let's see, I'll plot my y-intercept at 0, -5. My x-intercepts at -1, 0, and 5, 0. This parabola will be dashed because it's not equal. It's a little bit harder to make a dashed parabola. Now our shading's either going to go in here or on the outside. Notice this doesn't go through 0, 0, so I'm going to test that. So I'm going to see is 0 less than 0 squared minus 4 times 0 minus 5. 0 is not less than -5. That's false, so therefore we wouldn't shade where we have 0, 0 located. We would shade where it's not located. Alright, so there's 2 more examples for the linear and the quadratic inequalities.